In this example video, we are going to use experimental probability to make predictions. So our example is a manufacturer inspects 800 light bulbs and finds that 696 of them have no defects. So most of them are great. They did find some with some defects, but most of them are looking pretty good. What is the experimental probability that a light bulb chosen at random has no defects? So we are being asked to find the probability that there are no defects. So the probability fraction that we're going to set up, on the top we want the number of no defects divided by the total number of light bulbs. So if you look back at the problem, how many light bulbs had no defects? That was that 796 out of total number 800. So when we're finding probabilities to then make predictions, we're going to just go ahead and work with the decimal value on this. 796 divided by 800, if you grab your calculator, you get a 0.995. So that's a really high probability. It's 99.5% chance that your light bulb will not have a defect. So part B, the manufacturer sent a shipment of 2,400 light bulbs. So now we've got more light bulbs to a retail store. Predict the number of light bulbs in the shipment that are likely to have no defects. So we found the probability of no defects from, I guess we can consider it a sample space, to be a 0.995. So what we're going to do is we're going to apply that probability to the new shipment. So all we do is we take our probability of 0.995, we're going to multiply it by the number of light bulbs in the shipment. And that should tell us how many will have no defects. So when you take 0.995 and multiply it by 2,400, you get 2,388 light bulbs. Oh. Light bulbs with no defects. And again, this is just a prediction based on the fact that in our experiment we found that 99.5% of the light bulbs have no defects. So we applied it to our 2,400 light bulbs, and we can expect 2,388 light bulbs to have no defects.